We continue the topic of kinematics in physics. So today we talk more about speed and velocity. So in everyday life, we often use speed and velocity interchangeably. But in physics, they are related, but they are not the same thing. They are not the same. First, let's know more about speed. Speed is a scalar, so it only has a magnitude. The speed it does not have direction. Speed tells us how fast an object is moving, and in the international system of units, the unit of speed is meters per second. But speed also has other units. For example, kilometers per hour. And we can change the units of speed from one to the other. We can change its units from meters per second to kilometers per hour, or from kilometer per hour to meters per second. And speed is always positive or zero. We can see a speed of 5 meters per second or 10 kilometers per hour, even 0 meters per second. But we can never see a speed of negative 1 meters per second. So it's impossible. Such a speed does not exist. And in physics, we use this symbol to represent speed. And now let's talk about average speed. Average speed. Average speed is just a kind of speed. Of course, average speed is also a scalar. It only has magnitude. It does not have direction. And of course, it's also positive or zero. It can never be negative. And how to calculate average speed? Average speed equals the total distance traveled by the object and divided by the total time to travel the distance. Here there is a term distance. Distance is also a scalar, and we use this symbol v to represent average speed, and we use delta d to represent the distance, and we use delta t to represent the total time. Then we have this formula. So this represents average speed equals the total distance delta d divided by the total time, or we can call this time interval. We just use this formula to calculate the average speed. So let's see an example. For example, here is point A, and here is point B. There is a road between point A and point B, and a car travels from point A to point B along this road. and its span time delta t. And the total distance of the road is delta d. That the average speed of this car is just equals the total distance of the road delta d divided by the total time traveled by the car between point A and point B. Here notice that the delta d, the total distance, is the length of the road. It's not the straight line distance between A and B, not this distance. It's the actual length of the road. Now let's talk about velocity. Velocity is a vector. It has both magnitude and direction. Normally, we use this symbol to represent a velocity. The arrow on top indicates that this is a vector. The velocity is a vector. The unit of a velocity is just the unit of speed followed by an indication of its direction. And velocity can be positive, can be zero, and it also can be negative. For example, there is a velocity that is 4 meters per second. That here is e. This means that the magnitude of the velocity is 4 meters per second, and its direction is to the east. We said that velocity can also be negative, so there also can be a velocity that is negative 10 meters per second east. What does this mean? In fact, this velocity equals 10 meters per second, and the direction is west. In fact, this indicates that the object is actually moving to the west. Now let's know about average velocity. So there is average speed and there is also average velocity. The average velocity just equals the displacement of an object divided by the total time to complete the displacement. Normally we use this symbol v, to represent average velocity, and we use this delta d, this one, to represent the displacement, and we use delta t to represent the total time to complete the displacement. So that we get the formula. The average velocity equals the displacement divided by the time interval, by the time used to complete the displacement. And now we compare the formula of average speed and average velocity. So for the average speed, its formula is v equals delta d over delta t. And for the average velocity, its formula is v equals the displacement delta d over delta t. And they are similar, but they are not the same. One is a scalar and the other one is a vector. And now let's see a simple example to know the difference more clearly. For example, on the surface, the reference point is here, and there are two positions on the surface. Here is position 1, here is position 2, and the vector of position 1 is just this one, d1, and the vector of position 2 is just this one, d2. And an object move along this road from position 1 to position 2. Now, the displacement of the object is just the vector from position 1 to position 2. It's just this one. This is delta d. This is the displacement of the object. And the distance traveled by this object is just the length of this road. We use delta d to represent the total distance. From here, we can find that the magnitude of the distance is also different from the magnitude of the displacement. And now, the average speed of the object equals the total distance delta d divided by the time span to travel the total distance. And the average velocity of the object equals the displacement of it, delta d, divided by the time span to move from position 1 to position 2. Here, delta t, the time is the same, but the distance and the displacement are different. Not only that the distance does not have a direction, but also the magnitude of the distance is different from the magnitude of the displacement.